You also might want to pull out some highlighters or colored pens. We're going to kind of highlight up and group up our word problem to help us develop these inequalities. Let's start off by just reading through the situation to see what we have. It says your club plans to raise money by selling 2 sizes of fruit baskets. The plan is to buy small baskets for $10 and sell them for $16, and to buy large baskets for $15 and sell them for $25. The club president estimates that you will sell no more than 100 baskets. Your club can afford to spend up to $1,200 to buy the baskets. Find the number of the small and large fruit baskets you should buy in order to maximize profit. All right, the very first thing that I want you to do is look at that very last sentence. That's what we're always going to start off by after we read it for once. You might have to read it a couple of times, honestly. Sometimes I do. The last sentence is going to tell you exactly what we're looking for. So it says to find the number of small and large fruit baskets you should buy. And what that tells us is what we need to set our variables as. We're just going to use X and Y just because that's what you guys tend to like. It does not matter which type of basket you make, X or Y. Let's just say that X is the number of small baskets and Y is the number of large baskets. So again, that last sentence is telling you what to find. That is going to help us determine our variables, which is the first thing we need to do. Now, we are going to go back through, like I said, and we are going to group up the information that is all going to go in the same inequality. So it says that we are going to buy small baskets for $10. And we are going to buy large baskets for $15. And how much money can we spend on buying those 2 different types? Yep. It says you can afford to spend up to $1,200. So all of those like pieces of information are going to work together to form one of our inequalities. So remember that X stands for small, Y stands for large. So $10 for every small basket plus $15 for every large basket. And we can spend up to $1,200. So that means I could spend less than or equal to $1,200. Bless you. All right, let's look back, see what other information that we have. We're going to talk about selling them here in just a second. That's what usually goes into our objective function. The other constraint that we have here is that you will sell no more than 100 baskets. That's 100 baskets total. So between our 2 types of baskets, so between the small baskets and the large baskets, we will sell no more than 100. So we'll sell less than or equal to 100. Now let me ask you this. What's the least number of small baskets that we can sell? What's the least number of small baskets that we can sell? 0. Okay. I cannot sell a negative number of baskets. That is where our x is greater than or equal to 0 comes into play. So that is not explicitly given in the problem. So it's up to you guys to just understand that. Same thing with the large ones. I cannot sell a negative number of them. I can sell at least 0. Now, the last thing that we need to do to pull from our problem is get that objective function. This is typically, if you're talking about profit, this is going to be the money that you make, okay? So let's go back to our problem. Now, this one starts you off kind of, not tricky, but you have to think a little bit. You sell them, the small ones, for $16. Does that mean you make $16 on that? Why not, Colin? Exactly. All right. You only make $6 there. For the large basket, similar type of thing. You bought them for $15 and you're selling them for $25. So how much are you actually making in profit there? $10. You got it. Those are the values that will go into our profit function. Okay? That we get $6 for a small and $10 for a large. So we have our variables, we have our inequalities, we have our objective function. Now we're going back to exactly what we did on Thursday. Getting the graph, getting your corner points, finding the maximum, okay? So the one other thing that we need to do before we really jump into graphing is we need to set our axes and get those labeled out. So we know that from those first two inequalities that we are in quadrant 1 only. So when you set up your graph, keep that in mind, that we only need to focus, oops, I did a bad job there. So we only need to be working in the first quadrant. Grab a couple of your colored pencils. Before we set our axes here, our scale, what we're going to do is we are going to look at our two inequalities that we have written. And basically what we're going to do is we are going to look at the x and y intercepts. And that's typically how we're going to graph these. So let's look at the first one. So think back, I think this was the very first day of school when we talked about finding intercepts. So to find the x-intercept, we essentially plug in 0 for y and solve. So on your calculators, if we take that 1200 and divide it by 10, that gives us the x-intercept, 120. So make a note of that. So just like above, x-intercept is 120. Megan, how can we find the y-intercept? Sure, so that essentially gives me this. So what am I going to do on my calculator to solve for y? Say that one more time. Can't hear you. Right, but how do we solve for y then? Okay, we did that, and it leaves us with 15y is less than or equal to 1200. And then how do we get y by itself? Yeah, so we're going to divide 1200 by the 15. That gives us a y-intercept of 80. Okay, the next one's kind of easy. What are both the x and y intercepts on this one? 100, yeah. There's no coefficient, so cover up 1, x is 100. Over here, y is 100. Now, the reason why we did that first is because that tells us the maximum x and y values that I need to plot on my axes so that I can determine my scale. So if I have to graph all the way to 120 on my x-axis, you can kind of count up. If we go by tens, or excuse me, if we make every box 5 and go every 2 is a 10, 20, 40, 60, 80, 100. Does that work? Did I miss something? Let's see, 10, 20, 30, 40. Oh yeah, I was counting by 20s. 50, 60, 70, 80, 90, 100. That's not going to fit. See what I mean? So instead, why don't we make every box be 10 so that we fit 120? So if every box is 10, then every 2 is 20. And that allows us to fit on our scale that maximum x value that we need to plot. All right, now looking at our y-intercepts, the maximum y value that we need to plot is 100. So it might work on our y scale to go every unit is 5. You will always want to spread out your scale as much as possible. The more that you spread it out, the easier it will be to both graph and find your corner points. I always get people that try to scrunch their graph in just like the corner. The more that you spread it out, the easier it's going to be for you, okay? And then from here, it's just a matter of graphing these using the intercepts. So for the first one, our x-intercept is 120. The y-intercept was 80. We're shading below. For the second inequality, both x and y intercepts are 100. So you can plot both of those. And then using those intercepts, draw on your line. We're also shading below that. So basically our final shaded area is below both of these. So we're below the red one here, and then we kind of jump over and we're below the blue one here. also bounded by the X and Y axes. Really, we should know what we're doing from here. We're finding our corner points. We're using the objective function that we wrote to find, all we need here is our maximum value since we're trying to maximize profit. So let's go ahead and set up our chart that we've done in the past using our 6x plus 10y. Kale, what's one of our corner points? Okay. 0, 0 is certainly one of them. Travis, what's another one?
0, 100, or 100, 0.
There you go, 100, 0. Emily, what's another? It actually should be 60, 40. Yeah. And then the last one is our 0, 80. So this is why it's super, super, super important that we're really taking our time. I'm not saying you weren't, Emily, but that we get those correct corner points. Now, if I see that your graph is just slightly off and you did everything else correct, I usually take pity on you a little bit, but have to be showing me that you're trying to be as accurate as possible, okay? So from here, just again, plugging in those corner points to our objective function. So you can kind of do that on your own to see our maximum profit. Yeah, Allie?
So how come we didn't use like 0, 100, or 0, 120? Like the ones that are on the bottom.
So we used 100, 0. This is 100.
The same as, oh, okay, we use that one.
Yeah.
Okay.
And then we used 0, 80.
Okay.
Okay? So after we substitute those in, double check that you're getting the same values there, and we see our maximum, this is profit, remember, our maximum profit is $800. So the very last thing that we need to do is just write a statement making our conclusion. So basically, we could say something like the maximum profit is $800 when, and then we really need to go back to what these X and Y values represent. What did that X represent? So how many small baskets should we make? 0. Okay. And then the Y was the large baskets, and we should make 80. So the maximum profit is $800 when we make 0 small and 80 large baskets. So we want that final statement to recommend basically to this company what they should do. Okay, what questions do we have? The hardest part is getting those inequalities. I know it is. We're going to just keep working and keep practicing on that. Okay. Let's look at the next one. So I'm going to kind of get you started on this one, and then I'm going to have you guys finish it up. And then the last one we're going to try you guys on your own. All right, let's start off by just reading through. Mary works selling cards over the telephone. She sells 2 types of cards, birthday cards and holiday cards. Mary makes $2 for each pack of birthday cards she sells and $2.50 for each pack of holiday cards. She can work no more than 10 hours per week. Takes her an average of 15 minutes to sell 1 pack of birthday cards, an average of 20 minutes to sell 1 pack of holiday cards. If she can sell no more than 35 packs of cards, how many of each type should she sell to make most money? Okay, so again, there's a whole lot of information in there. You're not going to digest it all at once. That's not what I'm asking you to do. That's why we're kind of splitting this up. Again, start with that last sentence. How many of each type should she make or should she sell to make the most money? That last sentence is going to tell you what you're looking for and then basically what to make your variables. We can certainly use X and Y again. If you prefer different variables, then more power to you. Let's let X be the number of, what, birthday cards? And then Y be the number of holiday cards. All right, let's go back through, kind of group up the information that goes together. She makes $2 for each pack of birthday cards. And she makes $2.50 for each pack of holiday cards. That information is going to go where? Kaylee, say it again. That's going to go to our objective function because that is the money she makes or her profit. All right. So $2 for every birthday, $2.50 for every holiday. All right, let's go back. Let's look at more information. She can work no more than 10 hours per week. So all of her time is going to go in another inequality. Takes her 15 minutes to sell 1 pack of birthday, 20 minutes to sell 1 pack of holiday. So all of that information works together. So 15 minutes for every birthday. 20 minutes for every holiday. Now we got to be kind of careful here. She can work no more than 10 hours. $15 and $20 are in terms of what? Minutes. So we can't have minutes, and then an hour. So we're not going to write 10 hours. We'll write what? 600 minutes. Very good. Then the last piece of information, she can sell no more than 35 packs of cards. Between the two types, she can sell no more than 35. So between our holiday and our birthday, she will sell less than or equal to 35 packs. Isaac, what's the least number of birthday cards she can sell? All right, so X has to be greater than or equal to 0. Again, same thing with those holiday cards. All right, I'm going to let you guys finish this up, and I'll be around if you need help or have a question.